Hello everyone, welcome to my channel. In this video we are going to understand about circular linked list. So here the circular linked list means the pointer from the last element in the list points back to the first element. So normally in the linked list we are having the head and tail part in the linked list. So which are not which head will be the starting of the linked list and tail will be the ending of the linked list. But here the pointer from the last element in the list points back to the header point. So here it is going to point to the header point here back. Okay. So here the last element is going to point to the header point. That is the circular linked list. So since the pointing of the last to the first element is in the form of circular format, so it is called as a circular linked list. So a circular linked list is basically a linear linked list that may be single or double linked list. So circular linked list may be a single linked list or double linked list. So here we are taking the single linked list, right? So we can implement the circular linked list also with the doubly linked list. That means in the circular doubly linked list we will be having one part for the data item and two parts for the pointers, that is for the previous node and the next node. The only difference is that there is no null value in the terminating list. So normally in the singly linked list, normally in singly or doubly linked list, we will be having the terminating value, that is null value at the end of the linked list. But here there is no terminating value, where the last element will point to the starting of the linked list, right? In fact, in the list, every node points to the next node and the last node points to the first node. So thus it is forming a circular format, right? So here the last element points to the first element in the linked list. That's why it is in the format of circle shape. So it is called as a circular linked list. And in circular linked list, there can be no starting or ending nodes, right? So because the last element is pointing to the again to the first element, so we can traverse from any node to from anywhere to any node, right? So it will be easy to traverse in the circular linked list. In order to traverse the circular linked list only once, we need to traverse entire list until the starting node is not traversed again. Okay, so we need to traverse the entire list until the similar to the singly linked list. How in the singly linked list we can traverse every node only one time, right? Similarly here in the circular linked list we can traverse the entire list only once until we reach the header point from the tail. That means again we visit the last element to the header point. So at that up to that time we can visit every node in the list only once. A circular linked list can be implemented using the both singly linked list and doubly linked list. So we can implement it using single linked list and doubly linked list. So here in a circular linked list we are going to use a single linked list. So in the circular linked list we perform the following operations, that is insertion and deletion. Okay, and displaying how the values are inserted to the circular linked list. So now let us see the insertion operation. Similar to how we apply the insertion and deletion operations in singly and doubly linked list, similarly we can apply the insertion at the beginning of the linked list. So in the circular linked list, we are going to insert a new node at the beginning of the linked list. So for that, first of all, we are going to create a node using the struct node. So with the data and the next pointer, okay, and the start value is equals to null. So it is pointing to the null value in the header point. Okay. So next void insert. In the insert function, we are going to insert a new node. So we are going to create a pointer called new node. Okay. So we are going to create a pointer called new node here. So here we want to insert a new node at the starting of the linked list. So now, so consider the circular linked list. So this is the header, and so here we want to insert a new node here. So struct node means it will create a new node here with the pointer new pointing to the new node. Okay. So here when we are using the malloc function, it is going to allocate some memory for the new node. Next, printf enter the data. So here we are going to entering the data into the new node. Okay. Suppose I am going to enter the new node data as 1. If start equals to null, then start equals to new node. So that means the start means here header value. So if the header value equals to null, then head will be the new node. That means if there is no nodes in the linked list, then it will become the new node. That means if the header value is null, that means if the given value is null, then start equals to new node. So it will become the new node. Okay, and then new node dot implies next equals to start. That means new node implies next equals to start. That means it is going to point itself if the header value is null. That means there is no nodes in the linked list. Suppose if it is not like that, and we are having some nodes in the linked list, then what will happen? We are going to execute the else code. So here struct node start temp equals to start. So here the start means the header value, right? So we are going to denote the header value with the name start. Okay, that is S. So here the header value means S. Okay, so here start temp equals to start. That means that denoting a pointer value that points the header. Okay, temp. And if temp implies next not equals to start, that means until we are going to traverse it until we reach the ending of the linked list. And that means in the last node only the temp file, the next value is except the last node, remaining will be having the, you can traverse all these nodes, right? So this condition will satisfy until we reach the last node. Okay, so that means we are going to move the temp pointer to the last node. Okay, so when this temp pointer points to the last node, then what will happen? So temp equals to temp implies next. So we are going to traverse the temp value. And new node implies next equals to start. So here the new node. Okay, so here we have reached the temp pointer at the last. So this condition will fail and we come out of the while loop. So next, so new node implies next equals to start. So that is the next value of the new node equals to start. So that means we are going to point to this one, and start will become the new node. So this is the start value. The start pointer will point to the new node. Okay, and temp implies next equals to start. Okay, so the temp value. So temp implies next equals to start. That means, so we are going to point the header value to the new node. So like that we are going to insert the new node at the beginning of the linked list. So next one is inserting at the end of the linked list. Okay, so here also we are going to create the new node first of all by pointing the pointer to the new node, and then we are allocating the size here using the malloc function. So new node implies data equals to value. We are inserting the data, the value in the data part. So after that one, if we come to the if part, if head equals to null. So here the head value is null, not null, right? So we're having number of nodes in the linked list. So we'll skip this part, or else it will point to itself. If the head value is null, means the head will become the new node and it will point to itself, and it will become a single circular linked list node. But it is not. So we are going to skip this part and come to the else part. So in the else part, we are going to execute the next statements here. The struct node start temp equals to head. So we are creating a new pointer called temp here that points to the header value. And while temp implies next not equals to head. So we are here temp implies next not equals to head, right? So that means we are going to traverse to the linked list until we reach the last node. That means temp implies next not equals to head. So when we come to the last node, then this condition will fail and we come out of the loop. So we're going to traverse through the linked list until we reach the end of the linked list temp. So after that one, so temp implies next equals to new node. So here we have reached the end of the linked list, and here temp implies, so we'll come out of the loop and we are going to link the next part of the temp to the new node. So this is the new node that we have created. So we are going to link it to the new node. Okay, and new node implies next equals to head. So we have to remove this link between the already existing node and we have to link it to the new node. So we are going to link this one to the new node, okay, by removing this node. Okay, so we are going to link this one to the header point. So like that we have inserted the new node here with the data value 1. Okay, so here the insertion is successful. So like this we can perform the insertion at the end of the linked list. So next one is inserting at any position of the linked list. So here I want to insert a value after a particular node with the location and data value. Okay, so here I want to insert the node after the location 300 with the data value 1. So for that we have created the new node and then we are checking the header value is not equals to null and we are going to the else part. So in the else part, so we are making a new pointer to the header. So this is the header, right? So we are going to make a new point called temp here for the header. Okay, and temp implies data not equals to location. So we have to search the linked list for the location and data. So here I am taking the data as 1 and location as 3. So here we have to move the temp pointer through the linked list until we find the data and location. Okay. So while moving the temp to the next location, next node in the linked list, we have to follow these two conditions. That is, if condition. Temp implies next is equals to head. That means if we have reached the pointer has reached the end of the linked list and it is pointing, the next is pointing to the head. That means if the temp has reached the location 400, then given node is not found. That means we have traversed through the entire linked list at least once and the node is not found. Else temp equals to temp implies next, or else we have to traverse the temp to the next one. So when the temp reaches the location 300, then this while loop will fail and will come out of the while loop. And then new node implies next equals to temp implies next. So here we are having the new node. So new node implies next equals to temp implies next. That means we are going to insert the next value of the new node to the next value of the temp. So here is the next value of the temp. That is the last node, right? Okay. So we are going to move to we are going to link the next node of the new node to the next value of the temp. Okay, and then temp implies next equals to new node. So temp implies next equals to new node. That means we are inserting the new node to the linked list at any position of the linked list. So this is how we can insert the node in the circular linked list at any position. So next one is deleting at the beginning of the circular linked list. So here we are going to delete a node at the starting of the linked list. So here if head equals to null, here the head value is not equals to null. That's why we are skipping the if part and going to the else part. So here we are deleting another pointer called temp pointing to the header. And temp implies next equals to head. That means until we reach the last node of the linked list, we have to traverse the temp pointer. Okay. So if head equals to null, that means if the given value, the header value is null, then free the temporary value. Okay. So here we are going to traverse the temp to the ending of the linked list. Okay. So here temp implies next equals to head. That means the if condition is satisfied and the head equals to null. Right. Head equals to null means we are going to make the head value as null. Okay. And then we are going to free the temporary variable. Okay. So we are going to free the temporary variable. So here the temp value next equals to head, right? So that's why we are going to make the head value as null and free the temporary variable. That means we are removing the link to the first node in the linked list. Okay, after deleting this node, so division is successful. So next one is deleting at the end of the linked list. So similarly, how we have deleted the node in the starting of the linked list, like that we are going to delete the node at the ending of the linked list. So here in the linked list we are having the extra 2 pointers, that is temp1 and temp2. So head equals to null. So here the head is not null. So we are skipping the if part and going to the else part. So struct node start temp1 equals to head. Okay, so we are denoting a pointer temp1 that points to the head, and we are denoting the temp2 also, pointer temp2. So next one is if temp1 implies next equals to head. So temp1 next equals to head. That means if the temp next value is equals to head, then make the head value as null. But here the temp value next is not equals to head, right? So we are skipping this if part and going to the else part. While temp1 implies next not equals to head. So here temp1 implies next not equals to head, right? So that's why we are entering the while loop. Temp2 equals to temp1. So they are taking another pointer that points to the header pointer. Temp2 equals to temp1. And the temporary variable 1 equals to temp1 implies next. That means the temp1 variable pointer will traverse to the linked list. So it will visit the next node. Okay. So until it reaches the end of the linked list, it is going to traverse. So temp1 will reach the end of the linked list, right? So here the temp2 implies next equals to head. So after reaching the, so here the temp1 implies next equals to head, right? We are coming out of the while loop, and then so temp2 implies next equals to head. So we are going to move the temp2 variable to the next pointer and make the next value is equals to head. Okay, so we are going to remove this node and make this as the header value, pointing to the next header value. Similar to how we insert and delete the nodes at the starting and ending of the linked list. Similarly, we can delete the node at any position of the linked list. So here we are going to use a key value. So based on the key value, we are going to point to the particular node in the linked list and remove that node with the particular key value. Okay. So this is about the circular linked list. Thanks for watching my video.